Hello Internet, welcome to Antenna tutorial series. In this tutorial we are going to discuss slot antennas. Slot antennas are pretty simple. They are analogous to lambda by 2 dipole antenna as far as their radiation pattern and radiation mechanism is concerned, but their construction is different and they are featured under aperture antennas. Well, as the name suggests, the slot antenna is simply an opening in a sheet of conductor which is energized in some manner that eventually radiates the signal. And there are a few properties of slot antennas. They work on a specific principle known as Babinet's principle. So we are going to study Babinet's principle to understand why slot antennas were made and how are they better than lambda by 2 dipole antennas. And then we'll discuss about the impedance of slot antennas, and finally we'll discuss something about the feed mechanisms, and lastly we'll discuss about directional slot antennas. Now going back to the definition, as I mentioned in the definition, it's simply an opening cut in a sheet of conductor. So in other words, we'll have something like this. We'll have a sheet of conductor, and right within the sheet of the conductor we'll cut an opening, and this opening is really thin. So within the sheet of the conductor I've made this opening by cutting the sheet, and I've kept this width, let us say this is W, is really small. So now when W is taken to be really small, we try to imply that this slot in the sheet is exactly the opposite of a wire in the air. Now if we consider a wire with the same thickness W and the same length, now this is exactly the opposite of what we have here. This wire is a conducting wire and it has a perfect dielectric around it. On the other hand, here we have a perfect dielectric slot of air surrounded by a perfect conducting material. So this thing is exactly the complement of this thing. Now if we are getting a hold of this theory, it is very important to understand that this case of a wire surrounded by air is practically a dipole, and this thing where we have air surrounded by conducting material can be called as complementary dipole. Now, once we establish or understand that slot antenna is nothing but the complementary dipole antenna, then it will be a lot easier to understand the endeavor, the effort behind constructing a slot antenna. Now, this antenna takes into account a principle known as Babinet's principle, which is more popularly a principle of optics, but it is equally applicable to electromagnetics with some extensions, with some additional features. I'll talk about Babinet's principle for optics first. Now, Babinet's principle says that if we have a screen here and if we have a light source here, and this is our observation plane, or in other words, we could say that we've put a obstructive little sheet of paper in front of a wall, and this paper has a light source right in front of it. Now, courtesy this paper, you'll get a shadow here. So this thing will be the shadow caused by this screen, which is placed in front of the source. Now, let this screen be replaced by nothing, that is air. If we replace the screen, or if we remove this part with nothing, and if we add up screens elsewhere right in front of the wall. So in second case, what we are doing is we are putting screens elsewhere and we are leaving behind that part where screen was placed. So again, my focus is to understand the complementary things. So in these two cases, we are exactly trying to achieve complement of each other. We are trying to replace the area where screen was placed with no screen, and the area of no screen with screen. Now, courtesy this setup, we'll get shadows here. And if I say that I get some energy E due to the presence of screen at my observation plane, and if I get some energy E complementary screen because of this setup at some point in the observation plane, let us say that point is right at the center. We do not change the point in the setups, but we take up this random point. So this is the point of observation, and I'm getting ES. And if we give a nomenclature, it is the energy received at this point when the source is present, and this is the energy received by this point with the complementary source present on the same plane. Now, what Babinet said, that this is equivalent to the observation plane being the same and the energy received by this point from the same source with nothing here. So we have no screen here. So this E is equivalent to ES plus ECS. This is what the mathematical expression of Babinet's principle is. Of course, this holds true for vector quantities too, which will make more sense and logic when we move this optics principle to electromagnetics. Now, when we move this principle, when we take this principle to electromagnetics, what he says is that screen is analogous to a plane which is perfectly conductor to electricity. And he says that the complementary screen is perfectly conductor or conducting to magnetic fields or magnetism, you could say in simpler terms, because we do not have a concrete vector that he mentions, because he says that screen can be represented as something that has sigma is equal to infinity, that has no resistance to the electricity, and complementary screen would be some medium that would have mu to be equivalent to infinity. So the permeability of that medium should be infinite. It should not resist magnetism or magnetic field or magnetic charge, so as to say, in any which way. It is easier to comprehend sigma as infinity, but it's not easier to comprehend mu as infinity. This is a well-known fact. But anyhow, this thing is more of a theoretical thing, but what it does to our setup over here is that he says that if we consider dipole to be the setup of a dipole to be one thing, then the setup of a slot antenna would be complementary of that would govern some new rules which are applicable by the Babinet's principle. So I'm going to list those rules. Now, according to this principle, if dipole is placed horizontally, it will have a horizontal polarization. And if the dipole is placed vertically, it will have a vertical polarization. But if the complement of dipole now I'll introduce the term slot antenna is placed horizontally, it will be vertically polarized. And if it is placed vertically, it will be horizontally polarized. Now, creating a complement of an antenna would change the polarization of the antenna. That is the first rule that you need to remember, which applies to slot antenna also. That is really helpful. And I'll tell you about polarization now briefly, so that we should appreciate that this feature has resulted in improved performance. Alright, if we talk about polarization, let us draw some representative images. A horizontally polarized dipole would be something like this, which will be horizontal to the earth, and a vertically polarized dipole would look something like this. The wire of the dipole will be perpendicular to the earth. Now, this is easy to understand that the physical orientation of the dipole determines the placement of the dipole, and it is equally easier to remember that a horizontally polarized dipole would result in a wave which will be horizontally polarized. Now, any wave which is horizontally polarized would have the E vector parallel to the earth, and the H vector will be, of course, it will be perpendicular to the earth. Now, because of H being perpendicular to the earth, and earth being a very good conductor, it is going to dissipate all its energy. Whenever magnetic field is perpendicular to a conducting wire or a surface as specified by the Ampere circuital law, all the energy from magnetic field will be dissipated as charge into the conducting medium. So we would never want the magnetic field to be perpendicular to the earth. H perpendicular to earth is a big no, because it is going to dissipate all its energy as charge into the earth. In other words, the earthing of the wave will happen, and that is why we never recommend using a horizontally polarized wave as ground waves, where the wave has to touch the ground to bounce, because as soon as the wave reaches near the surface of the earth, the perpendicular magnetic field is going to dissipate all its energies into the earth, which is a perfect conductor. On the other hand, you would now understand that my electric field is perpendicular to the earth and my magnetic field is now parallel to the earth, which will result in no dissipation as induced effect. So no magnetic induction will happen at the surface of the earth, even if we make this vertically polarized wave bounce with the earth. Now, the placement of the dipole is very, very important. It is always easier to place the dipole as a horizontal antenna because horizontal dipoles offer much lesser resistance to the flow of winds. A perpendicular dipole will resist winds more and is more prone to damages. So our priority for the placement of the dipole is horizontal, and our priority for the polarization of the dipole is vertical. That leads us to a situation of dilemma as to what is the best solution for this. And the best solution is offered by the slot antenna, because if we place a slot antenna horizontally, I'll try to represent it, and if we make a slot and if we feed the slot through some coaxial cable, now this slot antenna is placed horizontally. This does not have to face a lot of winds, so this is going to send vertically polarized signals. So my electric field is perpendicular to the earth, my magnetic field remains parallel to the earth, which is good for long distance propagation, good for ground wave propagation, a better option nonetheless. So this was the first thing that slot antenna achieves. It simply changes the polarization of a normal dipole antenna into vertical polarization in horizontal position, which is a very, very good combination. The second thing that this dipole complementary dipole slot antenna achieves is the enhanced, which can be stated as rule number 2, enhanced impedance. Now, according to Babinet's principle and a little bit of mathematics, it says that the impedance of the antenna, which is considered as the screen, to multiplied by the impedance of the antenna, which is considered as the complementary screen, is equivalent to square of air's impedance upon 4. Now, in this case, in this specific case, our antenna which we have designed is the slot antenna, and we know that it was designed from lambda by 2 antenna, so we'll take the complementary of the slot antenna in question to be the lambda by 2 dipole antenna. And we also know that the impedance of a dipole antenna is 73 plus j 42.5 ohms, which is very less than the impedance of the air, which is 377 ohms. That results in a lot of mismatch and a lot of reflection. The reflection coefficient is not good at all for a lambda by 2 dipole antenna. Now let us put this value in this formula to get the impedance of our slot antenna. So we'll have this formula modified into this, and we'll put 377 as air's impedance and 73 plus j 42.5 as the impedance of dipole, which will give me an impedance close to 363 minus j 211 ohms. Now if we do not take the imaginary part or the reactive component of the dipole antenna, we get the impedance of slot antenna to be even better. So in both these cases, the impedance is a close match to the impedance of the air, which is a very good thing. So the second advantage of designing a slot antenna is to improve the impedance of the antenna itself so as to match with that of the impedance of the air. Now finally, I'd like to highlight some points on the feeding of the slot antenna and how various slot antennas can be combined together to form an array to improve directivity. I'll not go into the mathematics of this topic, but I'll throw some light, throw some ideas that might spark some interest. The slot antenna can be fed through a transmission wire arrangement, a parallel wire transmission line, and it can also be fed through a coaxial cable. Finally, it can be fed through a waveguide Now, if you are aware of the limitations and advantages of parallel wire transmission over coaxial cable and advantages of a waveguide over these two, then you would understand that which feed system would prove to be better than the other. Finally, I'd like to throw some light on using a waveguide as an array of slot antenna. What you can do is you could use a waveguide and you could create some slots at the face of the waveguide. Now what I've done here is I've created some slots over the top face of the waveguide. Now please understand the width of these slots would be dependent on the wavelength that you're going to be using in this waveguide. So it is bound to be lambda by 2, and the placement of these slots would depend upon the phase difference that you would want and the directivity that you would want. But just to give some sparks of idea, it is like having some slots on the surface of the waveguide, and they'll result in a much directional spurts of energy, which is improvement of directivity. So I hope this series of slot antenna tutorials was helpful, and you'd be able to understand the mathematics of the slot antennas in a much easier manner now. And as always, thank you so much for watching this video and supporting my channel. And if you found this video helpful, please subscribe to the channel. That makes a lot of difference to me. And you have a good day and a good life. Bye.